Hello everyone, so welcome to our video lecture. So dear students, in our last lectures we have studied about SN1, SN2 reactions. So we have discussed about Finkelstein as well as Schwarz reaction, about different applications of SN1 and SN2, comparison between SN1 and SN2. So now let us continue with the same topic. Here I am discussing with a particular reactions. So first of all, let's discuss about PCl5. Okay. PCl5. Now let us understand role of PCl5 in organic reactions. Okay. The structure of PCl5 is trigonal bipyramidal. Now PCl5 undergoes hydrolysis readily. Okay, when I say PCl5 plus water, 1 mole water, if I say, what happens? It forms POCl3 plus 2 HCl. Okay, right? Phosphorus pentachloride on partial hydrolysis forms POCl3 plus 2 HCl. Now if I say PCl5 plus water, excess means sufficient amount, it forms S3PO4 plus HCl. Okay, so here it is 4 water. Now if you check the reaction, what is happening here? You used for 5Cl, you actually needs what? 5 water. 1 water used POCl3 plus 2 HCl, already 2 HCl removed, so now it requires 3 mole of water only. So if I say 3 mole of water, then this will be formed POCl3 plus 3 water gives S3PO4 plus this HCl. Okay, means partial hydrolysis of PCl5 gives POCl3, and POCl3 plus water will give S3PO4 as the product, or by direct in this way. Clear? Now understand, in case of alcohols, in case of ethers, in case of acetones, in case of ketones, aldehydes, esters, and all oxygen containing compounds, there are reactions of PCl5. Why? It is a good dehydrating agent. Okay, you can see the reaction of phosphorus pentachloride with water. Phosphorus having oxidation number +5, here also it is +5. As we know the rule of hydrolysis, by hydrolysis the oxidation number of element remains same, which is undergoing hydrolysis. Okay, now let us take the example of organic compounds. So first of all, let me take a very example of CH3OH, okay, plus PCl5. So the product formed is, if I say CH3Cl plus HCl plus POCl3. Okay, now this is the product formed in this reaction. Clear? Now let me tell you the mechanism of this reaction. What may be happening? So you can see this is alcohol. So reaction of alcohol with PCl5 gives alkyl halide. So for the conversion of alcohol into alkyl halide, PCl5 can be used. Okay, the pathway here is SN2 type, back attack occurs. Okay, let me tell you mechanism. First of all, CH3OH, it is nucleophilic, right? And PCl5, as usual, this oxygen will attack on phosphorus. See, this phosphorus is having high delta positive charge due to 5 chlorine atoms on surrounding, which are highly electronegative. Okay, so when this attacks, this will generate one transition state, and finally this Cl will be removed as a Cl minus. So what you will get? You will get CH3OH, this gets plus charge, phosphorus, and then your Cl, 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 and Cl. Okay, because one Cl minus is already removed, right? Now what will happen? Now when I say again, then you have removed the Cl minus, which will take this H plus, right? Okay. Now what happens? That Cl minus removed will take this H plus, so H plus is removed by default. Okay, I can just draw it here. Right. Now here you are having now dear students, what happens? This oxygen, this phosphorus is having vacant d orbitals as well. Okay, so here this oxygen again forms pi bond, and then one more Cl minus is liberated, which will attack this chlorine, this methyl group from backside, and hence finally you can see it will form PoCl3 plus CH3Cl. Okay, so this Cl minus will be attacking from backside only. So this reaction favors SN2 type. Okay, and this is the method of conversion of alcohol into alkyl halide. Clear? Now I am telling you generalized form. Understand? If you are having PCl5 with ROH, what will happen? Just understand this shortcut. 1 Cl this side, 1 Cl this side. So what you will get? RCl, HCl plus rest PoCl3. 2 Cl is removed and replaced by oxygen. Okay, this is first case. Now we do not need to draw all the mechanisms for ether and other cases. Okay, see, if you are having ether ROR and you are given PCl5, again the shortcut will be from this side and this side. So you will get 2 moles RCl plus PoCl3. Clear to you? Okay. Third case. Suppose you are having ketone RCOR. Okay. Now this oxygen is also nucleophilic, right? See, here I am concluding with all cases of PCl5, right, in this reaction mechanism. Chapter wise, when we will go through organic compounds, organic chemistry, then we will discuss the reactions of PCl5 in haloalkanes and haloarenes. That particular part over there, reaction of PCl5 in aldehyde, ketone, carboxylic acid in that chapter, alcohol, phenol, ether in that chapter. Okay, here I am just discussing all cases of PCl5. See, RCOR when reacts with PCl5, it forms R. It will be having 2 chlorine R like this. Clear to you? You need not to draw all the mechanisms. You understand that part. Suppose you are having aldehyde. Aldehyde will also do same case. 2Cl. As I told you earlier, if this is reacted with aqueous KOH, you will get the same thing back, right? Next, what happens in case of carboxylic acid? So dear students, understand this case very carefully. See, this oxygen is pi bonded with carbon and this oxygen is single bonded with carbon. So remember one thing, which bond is easier to break? Single bond, right? So here what will happen? You get RCOCl plus HCl plus PoCl3. Okay, so what I have done in case of RCOOH, this part is broken. Okay, now next question. Suppose you are having ester RCOOR. Suppose, okay, if I am telling R1 and R2. Now what will happen here on reaction with PCl5? Again, see, although it is having resonance with this oxygen, lone pair single double conjugation, but you can understand it will not be having equal resonance, equivalent resonance. Means this part will be definitely having pi bond character more than this part. Means this bond length is obviously higher, so this bond can be broken easily. So the shortcut will be break this part and this part. So what you get? you get R1COCl plus R2Cl plus POCl3. Clear to you? Understand? Okay. So note down all the cases. Cyclic ethers. Now suppose you are having, in this cyclic ether you are having PCl5. So what you will get? POCl3 like this, okay? See, whenever you are having ether, remember it breaks from both the sides, okay? Means this will attack first of all, one Cl will attack from this side, one Cl will attack from this side. So what you will get? Okay, so this is the product you will get along with POCl3. Understand? Note it down. See, this is a case of anhydride. Okay, now when anhydride is considered, then remember, as I told you earlier, the bond breaking of sigma bond is feasible as compared to pi bond, because the bond energy of C double bond O is higher as compared to C single bond O. So C single bond O will be formed, broken. Okay, so this will form COCl and this will form COCl. Clear? Now next case. See this one. In this case, if I say this oxygen is in conjugation, but still if I say the reaction of PCl5, then it will occur, okay, normally as it occurs. CH2 plus CH3Cl plus POCl3. Here also along with this POCl3 only. Okay. Now next part. As I told you, ketone, that is okay, but sometimes you may come across this query that, sir, what about this conjugated system PHCOCH3? In this also the same reaction will occur, means it will form ClCl CH3 as it is plus POCl3. Okay, clear to you? Note it down. Now let's check the case of amide with PCl5. Okay. RCONH2 plus PCl5. See here I am just giving you a very shortcut. You just understand like this. R, it will form what? ClCl NH2, right? It will form like this along with what? POCl3, right? And now this nitrogen is having, this is a good leaving group, so it will form C double bond N, Cl minus will take this H plus. Now again it will form triple bond, this Cl will take this H. So finally what you are getting is R C triple bond N plus POCl3 plus 2HCl. Okay, so this is your product, right? From amide to cyanide. Okay, now when you say cyanide, or you can simply say it nitrile, you are getting nitrile here. So you may come across this shortcut in many places. In short, if I say what is happening, this water is removed. If you observe, see the observation, RC double bond O NH2 removes water due to PCl5. PCl5 acts as a dehydrating agent. It will remove water. You will get RCN. Now water plus PCl5 will give you 2HCl plus POCl3. Okay, this was your shortcut. Clear to you? Now this is one more shortcut. Just remove water plus PCl5. So finally this will be produced. Okay, so remember, only in case of amide what will happen? Dehydration occurs. In all other cases reactions are taking place. Okay, next come to the case of SOCl2. Okay, now when I draw the structure of SOCl2, now this is SOCl2. See, SOCl2 reacts with alcohol ROH plus SOCl2. It forms RCl plus SO2 as a gas is liberated plus HCl is removed as a gas which is liberated. Now you can understand the liberation of SOCl2 and HCl gas makes the reaction more towards product or forward side. Okay, now let us understand the mechanism. See, this reaction is actually SNI. Nucleophilic substitution intramolecular. Okay, nucleophilic substitution intramolecular. And here if I said about stereochemistry, then retention occurs. Clear? Okay, see this Cl minus liberated. Okay, what this Cl minus will do? This Cl minus will take again this H plus. Okay, so what you get? Minus HCl as a gas. Now HCl is removed. Now you get RO, H double bond O and this Cl. Okay, now sulfur is having lone pair as it is. See, sulfur is having vacant orbital as well, vacant d orbitals. That is why this reaction takes place very easily, readily. Now what happens? Again this will form H double bond O and hence this shifts this side. See, this is your intramolecular reaction. Okay, and hence retention in configuration occurs. Now what you will get finally? RCl and here minus SO2. SO2 gas is liberated. Okay, so finally you get RCl reaction, and this reaction is known as Darzan's reaction, or you say Darzan's process. Clear to you? So this is your Darzan's process, SNI, because here intramolecular reaction is occurring, okay, within the molecule. Clear to you? Characteristics of Darzan's process. Okay, so dear students, I discussed you about Darzan's process. So now let us understand what are the characteristics, main points which you have to remember. Thionyl chloride, first point. SOCl2, thionyl chloride, when reacted with alcohol, forms retention product. Now, how retention product? If suppose you are asked by statement, then remember living group means the living group you observed in the mechanism part. and attacking reagent are on same sides. Let me draw what it was found in the reaction. See, this was formed in the reaction, and what has happened? See, what do you call this one? It is called alkyl chlorosulfite. Okay, alkyl chlorosulfite. Now in this reaction, what happens? If you see the mechanism, you will find that here this group chlorine, this oxygen is having what? It forms pi bond towards this side. Okay, now this leaving group is leaving from this side, and attacking reagent also attacks from this side only. Okay, and then see what happens. This oxygen forms pi bond here. Then what will happen? Oxygen will get positive charge, so it will abstract more electron from this alkyl group, and hence this will get more positive charge. Then this bond will break, and this bond will shift towards this R. So this leaving group and attacking reagent are on same sides. See, leaving group from this side goes towards this side, and attacking reagents comes from that side only, and hence retention in configuration occurs. And since the reaction is occurring internally, okay, see, you have generated an attacking reagent internally in the reaction, hence it is substitution but internal. Okay, so it is your SNI reaction, substitution nucleophilic intramolecular, within the reaction, internal process. Okay, so it is SNI. Nucleophilic substitution internal process, or you call it intramolecular. Okay, clear to you? So this was all about SOCl2 thionyl chloride reaction. Okay, if you see this SOCl2, then it is also having lone pair. Okay, it is having hybridization sp2 sp3, one lone pair and 3 sigma bonds, sp3. Now there comes one more question. If it is sp3 having one lone pair, why the attack is occurring from this side only? And very easily, because this sulfur is having vacant d orbital, so it can hold the electron pairs easily, and the lone pair is delocalized in its vacant d orbitals. Okay, so I think clear to you. Now the question arises, if you have taken SOCl2 in presence of pyridine, not only pyridine, I am just telling you, generally one base is taken. SOCl2 is one, pyridine is one good base which can be taken here. Okay, in this case what happens? The product will be again same. It will be RCl plus SO2 gas produced plus HCl gas produced. Okay, but if I say here, then the mechanism followed in this reaction is SN2 favored. Okay, and here the product observed is inversion product. Clear? Now let us see the mechanism of this reaction. Why the process becomes SN2 type and the inversion product is formed. Understand it very carefully. Mechanism. See, first of all you are having ROH. As usual, we are having this SOCl2. This oxygen will attack. Okay, what you will get? You will get ROH. Oxygen will get plus charge, and then it will be connected with sulfur, right? Double bond O, Cl. Now when it attacks this side, this will get O minus type. Okay, So this sigma bond O minus Cl. Clear to you? Now this is your as it is. This is having one lone pair, right? Now what happens here? See, this will form again bond and this Cl minus will be removed. Okay, I am telling you very minute steps here. So Cl minus is removed. Okay, so you are having ROH plus charge S double bond O Cl. I am making this way. Okay, now Cl minus is generated. But here what happens, you know, pyridine is also present. So you are having now two nucleophiles, pyridine as well as Cl minus. Okay, clear? Now this Cl minus, rather than attack of Cl minus, this pyridine, what it makes, pyridine attacks on this hydrogen. Okay, clear to you? Now what you found? You found ROH double bond O Cl, and now you have plus and Cl minus. This is called pyridinium chloride. Clear to you? Now as this pyridinium chloride is generated, you are having Cl minus in bulk. Why bulk? Because this reaction is occurring in a container. You have not taken one molecule of SOCl2, pyridine and ROH. It is occurring in a container. So now you have generated this part, and accordingly lots of Cl minus has accumulated in the reaction. Now what will happen? This Cl minus as a nucleophile. Earlier what was happening? Earlier this was formed alkyl chlorosulfite, but internally the reaction was occurring. Here, in spite of this chlorine, the Cl minus produced in the reaction will directly attack this alkyl. Now see, this oxygen is having bond this side like this. Okay, so what you are having? This chloride ion will attack this alkyl group from back side. Okay, and now when back attack occurs, it is SN2 type. That's why I use the term SN2 type process is observed here. Okay, so now Cl minus will attack this from back side, and what you will get finally, what you get finally is RCl. Okay, and now this bond will break into this side and Cl minus will be removed like this, plus SO2 removed, plus Cl minus generated, and this you are already having. See, this you are having, and from this part only this Cl minus is consumed here. Okay, so you have generated another Cl minus here, which is along with what? This pyridinium chloride part. Clear to you? And hence you have generated the desired product, which is inversion product. So dear students, you can understand this mechanism. See, mechanism is not used in the reactions. You need not to make always in every reaction, you don't need to make the mechanism. But remember this thing, when you have been given SOCl2 with pyridine, definitely it will proceed via SN2 type. Inversion product will be obtained. Okay, so for general case, no need. But specifically, if the condition in the question is like the given configuration is R or S, then you have to remember this thing. Okay, inversion will occur here. Again, I am repeating once. ROH with SOCl2 pyridine. First of all, what happens? ROH reacts with SOCl2, thionyl chloride. So this will formed. Okay, it forms this side, this part. This will form this ROH SOCl2. Now this O minus will form double bond, Cl minus is removed. You are having Cl minus, but what happens? Pyridine abstracts this H plus. Okay. Now see what happens. The role of pyridine is to generate a stronger nucleophile in the reaction. How? Earlier you are having, in normal case, in case of only SOCl2, you are having weaker nucleophile. This chlorine, this was attacking intramolecular. Now what happened? This pyridine attacked on H plus. So you have generated Cl minus freely. So the role of pyridine is to generate a stronger nucleophile Cl minus in the reaction, and now Cl minus will attack. See, pyridinium ion is generated and Cl minus attacks. This was your separate part, okay, just to tell you. Here pyridinium part is separated and chloride ion part attacks on this R, and then this part SO2 relieved and Cl minus generated along with this pyridine. So pyridinium chloride, okay. So I think it is clear to you. Note it down properly. So dear students, in this question you have to find out the product, okay. See, if I check about the configuration of this 1, 2, 3 and 4, okay. It is going anti-clockwise, so S, but hydrogen in horizontal, lowest party on horizontal, so it is having R configuration, okay. Now what will happen when only SOCl2 is given? As you know, you will be having what? SNI, intramolecular substitution reaction, intramolecular nucleophilic substitution, and the product will be what? Retention product, because leaving group leaves from the side, and from that side only chlorine will attack, okay. Now when you say SOCl2 with pyridine, there will be inversion product. So here you get CH3 and deuterium as it is, hydrogen comes this side, chlorine comes this side. Clear to you? Okay, now third case. In third case, if I say also, see here instead of pyridine I have taken NMe3. See, this is also a base, okay. Now the role of this nucleophile, role of NMe3 is to generate stronger nucleophile in the reaction. So it will also proceed via SN2 type. And the product will be CH3, D, Cl and H, okay. If I say this one, retention, this is inversion, and this is also inversion. So this is your SN2 type, this is your SN2 type. Clear to you? Note it down properly. Now let's come to PCl3 reactions, okay, in organic chemistry. So when I say PCl3, one lone pair, it is having tetrahedral geometry, but if I say specific structure, then it is trigonal pyramidal type, right? Tetrahedral geometry as it is sp3, and it is having trigonal pyramidal structure, okay. Now see what happens. ROH plus PCl3, if we say, then it forms RCl plus S3PO3, okay. Now if I make the balanced equation, then it is actually 3 times ROH, which forms 3RCl plus S3PO3, okay. See, 3R, 3R, 3Cl, 3Cl, 1 phosphorus, 3 OH. But if I say this one, it is having phosphorus with 3 chlorine. It is not having, it is not like this. It is actually this is your phosphorus acid, okay. Now if I say for this acid, the basicity equals to 2, not 3. Remember, this is one of the good question arises, okay. Here you are having inorganic compound which reacts with organic compound, okay. Clear? So basicity is 2, so it is called as, this S3PO3 is known as what? Dibasic acid. Okay, clear to you this part? Now here this reaction goes again via SN2 type, means inversion product is obtained. Inversion product is obtained in this reaction also. Okay, so let us see the mechanism. Note it down first of all. See, we have ROH and we have phosphorus with three chlorines and one lone pair as well. Okay, now as you know that phosphorus is having vacant d orbital. Okay, it is of third period, so it is having vacant 3d orbitals. So the lone pair of this phosphorus is dispersed or delocalized in its own vacant d orbital. Now due to these three chlorines, it is having partially positive charge, and this oxygen lone pair can attack very easily in this phosphorus. So what you will get? When this attacks, it will remove Cl. This Cl will be removed. Okay, so you get in this part ROH plus charge phosphorus having chlorine and chlorine. Okay, see, I have removed one Cl. This bond will be removed like this. Okay, Cl minus will be removed, minus Cl minus. Now this is produced. Okay, now when I say this part is produced, the major part what happens here is Cl minus can attack this hydrogen. Okay, that is one possibility. Another possibility is Cl minus will attack this alkyl part, R group. Now when I say this oxygen is having plus charge, so in spite of this H, this alkyl group is having highly positive charge, and if you say the product as well, you won't have formed HCl. Okay, so it is product based reaction. So this is a probable mechanism of this reaction. When we say probable mechanism, means nobody has observed that the reaction is proceeding via which path, but it is probable. Okay, probable means probably as per the product formed in the reaction, we are assuming that reaction might have forwarded or gone through this mechanism or this pathway. Clear? Actually what happens in organic chemistry, most of the times what has occurred is practical observations, and those practical observations are taught to you here based on theoretical part. How? What happened? You have taken alcohol in a container, you have added PCl3, finally you produced what? Alkyl halide as well as S3PO3. Now earlier the known samples were PCl3 and ROH, final products were S3PO3 and RCl. When products were obtained, they were separated and their properties were observed by different methods, physical and chemical methods. Then it was formed that one part is S3PO3, other part is RCl. Means the product is obtained is RCl and S3PO3. So here you cannot make HCl. Now here what happens actually? Cl minus primarily attacks this alkyl part, and this will form neutral part, and hence you get RCl plus POH Cl. Clear to you? So this mechanism is observed. Now when I say that attack has occurred from backside, now you can say it is SN2 type mechanism observed in this reaction, and hence inversion product will be formed. Okay, if it is having chiral center, then definitely from this chiral center there will be inversion product only. Clear to you? Now this one RCl is formed, one Cl is removed and OH is generated. Okay, so this is first mole of ROH consumed. First mole. Okay, now again ROH, second mole, same method, you will get what? RCl plus POH OH Cl. First, this is your second. Now again what? You are having third mole ROH, and finally you get what? Finally you get again RCl. This is your third mole. Okay, plus POH OH OH, right? Now the question arises, sir, RCl 3 moles, inversion product, all these are okay, but what about this POH whole thrice? Because as you told earlier, that's why I only told you the molecular formula and structure of this H3PO3. So what happens, dear students, this formed part is not stable as it is, okay? So it internally rearranges into what? Rearranges like this. Internal rearrangement, and it forms a POH, OH, 2OH, 1H and P double bond, okay? In this way. This lone pair will form double bond and this hydride shift hydrogen will get with phosphorus. Clear to you? Due to internal rearrangement, this POH whole thrice formed in this reaction rearranges into PO, P double bond O, H and 2OH. Clear to you? So finally you can see SN2 type mechanism, 3 moles of RCl is formed in the reaction. Okay? Note, PCl3, when I say SN2 type, inversion occurs and reaction occurs. Now when I say PBr3 or PI3, same, SN2 inversion, okay, it will occur. So remember, dear students, just like PCl3, if you are given in any reaction PBr3 or PI3, then same reaction, same mechanism will only occur. Now one thing to be noted here is, actually, you know, instead of PBr3, it is actually freshly prepared always, okay? This PBr3 or PI3 is freshly prepared for these reactions. So what is given to you in the reaction? In place of PBr3, if you are told P plus Br2 or you are told P4 plus Br2, then remember it is nothing but PBr3 only. Similarly, instead of PI3, you have been told P plus I2. So don't worry, it is PI3 only. In situ preparation of PI3 or PBr3 via these forms, okay? In the lab, what happens? Firstly, these are taken to prepare PI3 freshly and then reaction is carried out, okay? So rather than PCl3, PBr3 or PI3 can be used in place of PBr3, P4 plus Br2, or in place of PI3, P plus I2. It can be given to you. So don't forget this thing. Clear? Now again, the question arises, sir, if it occurs, then what about PCl5 case? PCl5, as I told to you, SN2 type observed, inversion only occurs, it is done. Now first question is, PCl5 in gas phase or solid phase? So PCl5 gas phase, that is also okay. PCl5 solid phase, it is what? PCl4 plus PCl6 minus, okay. So this PCl5 in solid state exists like PCl4 plus and PCl6 minus. Clear? Now what will happen? If you take alcohol with PCl5 solid, then first of all reaction will occur with PCl4 plus, okay, and in the last step this will be attacking reagent from backside and hence it will be again same. Whether you take gaseous form or solid form, it will be SN2 inversion type only. Clear to you? Okay. Now here comes PBr5, it won't occur. PI5, it won't occur. Okay. Remember this thing. Clear to you? Okay. In case of PBr5, chlorine is having a better nucleophile to be attacked. Okay. But in case of bromine and iodine, it is not feasible. So this reaction won't occur in PBr5 or PI5. Clear to you? Note it down. So, dear students, here I have taken one reaction. Here you have to observe whether which product will be formed, inversion or retention. So, from this one question, you can revise all the concepts discussed in this video lecture. Okay. See, this is 1, CD3 2, 3, 4. So, if I check the configuration of this lowest priority group on dash position away from you, so it is anti-clockwise. So, it is S configuration. Okay. Now, when PCl5 reaction occurs, it is approximately SN2 type. So, inversion product will be happen. OH is towards you. So, Cl attached will be away from you. So, the product will be what? Inversion SN2 type. Okay. When I say PCl3, it is also again inversion SN2 style. Okay. Now, when I say SOCl2, it is what? It is retention SNI, intramolecular nucleophilic substitution occurs. Clear to you? So, you will get retention. Means when I say inversion, OH is removed and rather than wedge, dash position will be Cl. Means HOH will be interchanged. Right? When I say retention, in place of OH, only Cl will be attached. Now, when I say SOCl2 with pyridine, again it forms what? Inversion SN2 type. Clear to you? So, from this question, I hope you have understood. Now, I am just drawing here what is retention and what is inversion. Retention means carbon attached with methyl this side as it is, CD3 as it is, Cl and hydrogen here. Okay. Now, when I say inversion means carbon having methyl this side, CD3 this side, Cl goes in dash, hydrogen comes here. Okay. So, you can check in this one, this is your retention, chlorine in position of OH, and this is your inversion. Okay. So, from these things, you can relate this one. Clear to you? Okay. So, PCl5, PCl3 and SOCl2 pyridine inversion, SOCl2 only inversion. Okay. So, dear students, here we have discussed about applications of SN2 reaction and about SOCl2 pyridine case, SOCl2 reactions of PCl3 and PCl5 with alcohols. So, all these reactions were about conversion of alcohol into alkyl halide. If I say the best method among these will be reaction of alcohol with SOCl2 to produce RX. Why best method? Because in this reaction it is thermodynamically favored, because SO2 and HCl is gas, it is removed in the reaction, so the reaction will proceed more and more towards product side. Okay, so we'll continue in our next lecture.